There's a couple of different versions of multiplication. Now, that's not true. There's one version of multiplication, but we're going to present it in a couple of different methods. The first way that we're going to talk about it is specific to what kinds or types of polynomials that we're going to multiply together. And this first instance, we're going to do a monomial. Let me highlight that, actually. We're going to do a monomial times the polynomial. And to do that, what we're going to do is we're just going to use some simple distribution. Right? So, distribution. And so this is equal to a 5x squared times a 3x cubed plus a 5x squared times a negative 2x squared plus a 5x squared times 7. So we're using distribution, and we distribute the monomial to each term in the polynomial. And then, of course, simplify here. And again, this is very similar to what we talked about in our first couple of videos here. This is 15, and then when we multiply those powers of x, that's x squared plus 3 more powers, minus 10, x to the 2 plus 2, plus 35x squared, which simplifies to be 15x to the 5th minus 10x to the 4th plus 35x squared. And that is our final result. So, distribution. This next one is pretty classic stuff. It's taught in a very specific way. This technique, students are taught to what's called FOIL. That's an acronym for first the outers, the inners, and the last. And so what they're talking about is going through this in a specific instance. On our polynomial, these are the first terms in our binomials. Binomial, again, meaning 2 here. So we're going to do the first times the first. So here the first times the first is 2x times 4x. The next one we're going to do is what are called the outers. Those are the two that are farthest away from each other. Really, it's just distribution term by term like we had done above. The outers here are going to be 2x times 2. Oops, I don't want to use purple. That one's hard to look at. The innards, let me do that one up top, actually. Those are the inner tubes. The inner two are negative 3 times 4x. And then finally, I guess I'll just use blue. I haven't used blue yet. So the last two, and that's going to be a negative 3 times 2. And then, of course, we simplify each one of these. This is 8x squared. This is 4x. This is negative 12x, and this is negative 6. And then we add them all together, 8x squared, positive 4x, negative 12x, negative 6. And then if we have any, we combine like terms. That is to say, arrange everything in piles. And this is 8x squared. 4x minus 12 more x's is a negative 8x minus 6. And that's our final result for this FOIL technique. Sometimes it's referred to as the eagle claw, right? I like that name. Anyway, I think that they're referring to the fact that when you draw these little rainbows here, it looks like an eagle claw. Anyhow, This next technique for polynomial times polynomial is a technique I suggest everybody uses. You can even use it in that previous binomial times binomial because this can get a little bit confusing. Technically, all you have to do is take this first term and multiply it or distribute it to every single term in the second polynomial, and then take the second term in the first polynomial and distribute it to every single term, and then take the third term in the first polynomial and distribute it to every single term. And that can get really confusing, especially when you're keeping track of how many are you supposed to get. Well, there's 3 terms in the first polynomial, 4 terms in the second polynomial. That's a grand total of 12 different calculations you have to make. And that's not the way that I suggest you do it. What I suggest you use is what's called the grid method. Now, the grid method is, or sometimes it's called the tic-tac-toe method, but this isn't necessarily 3 by 3. What you're going to do is you're going to take one of your polynomials, usually the second one, 2x cubed plus 7x squared minus 3x plus 5, and write it out horizontally and space out the terms a little bit. And then for your second or your first polynomial, you're going to write it vertically over here. So x squared, negative 3x, and 2. And then what you're going to do is you're going to make a grid. A series of boxes. And these are generated term by term, so to speak. So that is, that 2 gets its own row, negative 3x gets its own row, x squared gets its own row, 2x cubed gets its own column, 7x squared gets its own column, negative 3x gets its own column, and 5 gets its own column. And then what you do is you fill out every single one of these squares, and you'll notice that there's 12 squares. And each square, like this one that I've colored in here, is the product of the row and column. So this particular result is going to be negative 3 times 7, which is negative 21, and x times x squared is going to give us an x cubed. And this way we can systematically make sure that we get all of our terms by filling out the entire chart here. So let's do one more. We get a different color. For example, this square is the product of that row and that column, which is x squared times negative 3x, which is negative 3x cubed. So filling this out really quick, we're going to get a 2x to the 5th, a 7x to the 4th, a 5x squared, a negative 6x to the 4th, a 9x squared, a negative 15x, a 4x cubed, 14x squared, negative 6x, and 10. And another thing that you might notice, if these are fairly well behaved, is when you collect like terms, they happen oftentimes, not always, but often, along these diagonals. So actually, let me back this up here. So a little bit of overkill here, but this is 2x to the 5th. Now this next one is 7x to the 4th and negative 6x to the 4th, which is a grand total of 1x to the 4th. That kind of looks like a weird 7. Let me erase that. One. Our next diagonal, let's see if we can keep track of this in our head here. Negative 3 minus 21 more is negative 24, plus 4 is negative 20, x cubed. And then let's see, 5 and 9 is 14, and 14 again is 28x squared. Oops. Not sure why that zoomed in like that. Let's see, negative 15 and negative 6 is negative 21x. And then no work in that last diagonal. We just get a positive 10. And that is our result of this product. Now, we did in fact have 12 terms, but some of those combined, and overall when we were done combining them, we actually only had 6 terms total. But that's the result.